everyone, welcome back. In the previous lecture, we discussed nested list and tuples. Today, we are going to complete Unit 4 by learning some important concepts. Number 1, dictionaries and dictionary operations, dictionary methods, sparse matrices using dictionaries, aliasing, shallow copy, and deep copy. These concepts are very important because they help us store and manage data efficiently. So let's begin with dictionaries. Okay, so let's start. Okay, so introduction to dictionaries. A dictionary is another important data structure in Python. Unlike lists which store values using positions or indexes, dictionaries store data using key value pairs. A dictionary connects one value with another through a key. The basic structure is key value. Okay, you guys can see here it's written Python dictionaries store data as unordered collection of key value pairs. Keys must be immutable, strings, number, tuples, and map to values of any time. Dictionaries provide constant time average lookup, making them ideal for associative data. Okay, so for example, here you can see it's an example of key value pairs. In here, where's the cursor? Okay, so this is key and this is value. Okay, name is a key and Rahul is the value. And in here, age is the another key and 20 is its value. Okay, okay. So you might have a question why we use dictionaries. Okay, so dictionaries are useful when we want to represent relationships between data. For example, student information. Okay, so here student ID for like here student ID, student details, okay, record or whatever you can say. Dictionaries are provide nay, dictionaries provide a natural way to represent these mappings. Okay, so real world examples of dictionaries. Dictionaries are used in many applications. JSON data. Okay, many web applications exchange data using JSON. JSON objects are similar to Python dictionaries like this. Name is equal name Rahul age data. Okay. So configuration file means software settings are often stored as key value pairs. Example theme is dark, language is English. Okay, and frequency counting. Okay, so dictionaries are commonly used to count occurrences. Example, word frequency in a document. Okay, so graphs representation. Graphs can be represented using dictionaries. A node can map to its connected nodes. Okay, just wait. Okay, so dictionary keys and value. A dictionary contains keys and values. You guys have to remember this, okay? And you guys can see the example. And there are rules, okay? Dictionary keys must be immutable. Example of valid keys are strings, number, tuples. For example, here you can see name is equal to Rahul. Just wait. Okay, and one more thing, that keys cannot be list because list can change. Okay, okay. So if you want to write these things in your notebook, you guys can do it now. Okay, so now let's begin. Creating and accessing dictionaries. Okay, so there are multiple ways to create dictionaries. Okay, so using dictionary, Python, Python also provides the dict function. Okay, so dictionary comprehensions. Python also supports creating dictionaries using comprehension syntax. This allows us to generate dictionaries dynamically. Okay, so accessing values. Okay, so there are two common methods. Number one, using square brackets, and number two, using gate. Okay, gate you can use, and here square brackets. Okay, so using square brackets. Okay, in here you can see if we write student, just wait. Okay, student name, the output will return us as Rahul. Okay, just see this, okay. But if the key does not exist and we write student marks, Python gives us error because we have we haven't, just wait, okay. Okay, so let's start. Okay, so using get. The get method provides safer access. For example, student.get name. Okay, so the output will return as Rahul. If the key is missing, just like we write student.get marks, it returns none. Instead of getting an error, we can also provide a default value. Okay, so now adding new dictionaries elements. So dictionaries are mutable. That means we can modify them after creation. For example, here you can see grade is equal to A. So now the dictionary becomes name Rahul, age 20 and grade A. A new key value is added. Okay, so set default method. So this method adds a value only if the key does not already exist. For example, here you can see, just wait. Okay, so updating values. Okay, so we can update existing values. For example, here you can see student age is equal to 21. Now age becomes 21. Another method, update. Okay, so here you have seen student dot update age is equal to 21, grade is equal to A. This updates multiple values together. Okay, so if you want to remove dictionary elements, there are different ways to remove data. Okay, so here we have delete statement. So for example, del student grade. Okay, this removes the key grade. Okay, and student pop, it removes the key and return its value. To avoid errors, we can provide a default value. Okay, so here you can see student dot pop grade comma none to avoid exceptions. Okay, so for checking dictionary membership, we use in to check whether a key exists. For example, name in student, output will be true because name is present, so that's the reason. Okay, so dictionary methods. Python provides useful dictionary methods. Main methods are keys, values, items, gate. Okay, so the key method returns all the keys. For example, student.keys. So so the output will give us name, age, grade. It is useful when we want to iterate through keys. Okay, the second one is values. The values method return all the values. For example, student.values. It is useful when we only need the data values. Okay, third one is items. The items method returns both key and value pairs. For example, student.items. So it will give us name Rahul. So the age and 20. This is commonly used in loops. Okay, so looping through dictionaries. Just wait. Okay, so looping through dictionaries. Now let's understand how to iterate through dictionaries. Iterating keys. Okay, for example, for key in student, print key. This print keys. Okay, so coming to iterating values, for example, for value in student dot values. So this will print only these values. Iterating, iterating key value pairs. The method common, the most common method for key value in student dot items. This gives both key and values together. Okay, so note it down in your notebook. Okay, so now let's learn about sparse matrices. A metric is called sparse when most of its elements are zero. Okay, for example, a large matrix may contain thousands of values, but most positions contain zero. Storing all zeros wastes memory. So problem with normal matrix storage is that suppose we have a very large matrix. If we store every element, memory is used for non-zero values and zero values. But zeros do not provide useful information. This wastes storage. Okay, so dictionary representation of sparse matrix. Just wait. A dictionary provides an efficient solution. Okay, instead of storing all values, we store only non-zero values. The key represents row and column. Okay, the value represents the actual data. For example, just wait. Okay, so for example, here you see the example 0, comma 1, colon 2, comma 3, colon 10. This means row 0, column 1 contains 5. Row 2, column 3 contains 10. All other positions are assumed to be 0. Okay, so accessing sparse matrix values. To access a value, we use get. Okay. For example, you can see. Okay, so this means if the position exists, return the value. Otherwise, return 0. This avoids error. Okay, for updating sparse matrix to add a value, just wait. Okay, for updating a value, for example, aij is equal to value. If the value becomes 0, we can remove that entry because storing 0 is unnecessary. Okay, so I hope you guys are clear with this topics. Okay, so coming to the next part, aliasing in Python and copying list. Now let's understand an important topic, aliasing. Aliasing means multiple variables refer to the same object. For example, here you can see A is equal to 1 to 3, B is equal to A. Here A and B point to the same list. They are not separate list. Okay. So effect of aliasing. If we modify B B0 is equal to 99. The list becomes 99, comma 2, comma 3. Now if we print A, we also get 99, comma 2, comma 3. Why? Because both names refer to the same object. So why aliasing can be problem? Aliasing can create unexpected changes. Sometimes we modify one variable thinking it is separate, but because both variables refer to the same object, the original data changes. This can create bugs. Okay, for copying list, to create an independent list, we need copying. There are two main types. Number one is shallow copy, number two is deep copy. So, a shallow copy creates a new outer object. For example, A is equal to 1 to 3, and if we write A dot copy, so now A and C are different lists. Changing C does not affect A for simple elements. However, if the list contains another list, nested objects are still shared. For example, A is equal to 1 to 3 and 3 comma 4. There are three lists, okay, because in the list there are more two lists, okay. So a shallow copy copies the outer list but not the inner list. Okay, coming to the deep copy. Deep copy creates a completely independent copy. Python provides import copy. Copy dot deep copy. Deep copy replicates all the nested objects. So changes in one copy do not affect the other. Okay. So now let's compare shallow copy versus deep copy. Okay. In shallow copy, it creates new outer container. But in deep copy, it creates completely independent copy. In shallow copy, nested objects are shared, but in deep copy, nested objects are also copied. Okay, and shallow copy is faster, and deep copy requires more memory. Okay, so unit 4 is completed. So let's summarize everything we learned in unit 4. We learned strings. We learned strings basics, indexing, slicing, traversal, searching, comparison. In list, we learned creating list, accessing elements, list operations, updating values, deleting elements, passing list to functions, nested list and tuples. We learned two-dimensional list, matrix representation, tuple creation, tuple immutability, returning multiple elements, values. Okay, we learned dictionaries. In dictionaries, we learned about key value pairs, creating dictionaries, accessing values, dictionary methods, looping. We learned about sparse matrices, why storing zero is inefficient, dictionary representation, efficient memory usage, aliasing and copying. We learned multiple references to one object, shallow copy, deep copy. Okay, I hope this lecture is helpful for everyone. Okay, so now there are some questions. Okay, so you guys have to do it by your own. So number one, what word frequency counter? Use a dictionary to count word occurrences in a text file, handle punctuation and case normalization. Here you have to create a dictionary that counts word from a text. Okay. In number two question, design CRUD operation for student records using dictionaries keyed by student ID. Here you have to create a dictionary based student record system. Perform as student, update details, search student. Okay, in number three question, you have to implement sparse matrix addition and multiplication using dict representations, profile memory versus dense approach on large inputs. So here you have to implement matrix operation using dictionary representation, compare memory usage with normal matrices. Okay, and unit 4, in no not in number 4 question, you have to create nested list and observe the difference between number 1 aliasing, shallow copy, deep copy. So this completes Unit 4. In this unit, we learned different ways to store and manage data in Python. Strings help us handle text. List help us manage collections. Tuple stores fixed data. Dictionaries provide fast lookup. Understanding these structures is very important because almost every real-world Python program uses them. Keep practicing these concepts and try solving problems using these data structures. Thank you.